we need to know that if we work out the upper bound of a sum, so the upper bound of a plus b, we would work out the upper bound or the maximum of a plus the upper bound or maximum of b. Similarly, for the minimum of a sum, we need to do the minimum of each of the parts of the sum. For a difference, so if I want the maximum of b minus a, I would do the maximum of b, take away the minimum of a. And that should be quite sensible, because you want b to be as big as possible, and you want to take the smallest possible value from it. Similarly, b minus a, the lower bound of this would be the lower bound of b, take away the upper bound of a. And it's very similar with multiplying. The maximum of two positive numbers, so assuming that a and b are positive, the maximum of a times b is going to be the maximum of a multiplied by the maximum of b. The minimum of a times b is the minimum of a multiplied by the minimum of b. And probably the most tricky to understand is that the maximum of a divided by b is the maximum of a, so basically the top of the fraction needs to be as big as possible, divided by the minimum of b. This is because if we divide by something smaller, our answer will get bigger. If I do 20 divided by 5, we get 4, but if I do 20 divided by 4, we get 5. Our answer has got bigger. If I do 20 divided by 0.1, I get 200. But if I divide by 20 divided by 0.01, we get 2000. Our answer's got bigger. Similarly, the minimum of a over b, or a divided by b, is the minimum of a divided by the maximum of b. Because if we make our denominator larger, so if I do 20 divided by 100, we get 0.2, our answer gets smaller. Here's an example of where we'd use this, typically in an exam. The acceleration of a particle is given by the formula a equals v minus u over t. U is the initial velocity of the particle, v is the final velocity, and t is the time taken for the motion. We are given some values, and they're not accurate values, so we have u is equal to 10 to the nearest meter per second, v is 25 meters a second to the nearest 5 meters a second, and t is 20 seconds to the nearest 5 seconds. We want the upper and lower bound for a. So, first of all, looking for the upper bound of a, so we could say ub of a, upper bound of a, this is going to be the upper bound, or the maximum, of v minus u, because we want the numerator to be as big as possible, divided by the lower bound of t, because we want to divide by the smallest number possible. Now this is going to be the upper bound of v minus u on the top is given by the upper bound of v take away the lower bound of u, because we want the largest value taking away the smallest possible value. And then the lower bound of t on the bottom, that doesn't need any changes here. And now we can put the numbers in. The upper bound of v, 25 to the nearest 5 meters per second. As we saw before, we need to add on half of 5, which will give us 2.5. So we end up with 27.5 as our upper bound for v. Take away the lower bound for u. This is to the nearest meter per second. So the lower bound of u is just 9.5 meters per second, divided by the lower bound of t, 20 seconds to the nearest 5 seconds. So we need to do 20 take away 2.5, which is going to be 17.5. So on the top, we have 27.5 take away 9.5, which is just 18, and on the bottom we have 17.5. So we need to type into our calculator 18 divided by 17.5. This gives you 1.029, or approximately 1.03 meters per second squared, because the units of acceleration are meters per second squared. To find the lower bound of a, on the other hand, we would need to do the lower bound of v minus u, which is going to be the lower bound of v, take away the largest possible value or upper bound of u, divided by the largest possible value or upper bound of t. We can now substitute in the lower bound of v, which is going to be 25 take away 2.5, so we have 22.5. Take away the upper bound of u, which is 10.5, divided by the upper bound of t, which is going to be 22.5. So, on the top, 22.5 take away 10.5 is just 12, and on the bottom we have 22.5. So putting this into our calculator, we get 12 over 22.5, which is 0.53, which is dramatically different really, 0.53 meters per second squared. And it makes sense that it's dramatically different because we're measuring with a high degree of inaccuracy. You're measuring the time to the nearest 5 seconds and the final velocity to the nearest 5 seconds. So because you're measuring with such a degree of inaccuracy, it makes sense that the possible values for A are so different. Here's a question for you to try. Please pause the video now and have a go at it, and when you're ready to go through the answer, press play. Okay, let's go through the answer. So in this question, we are looking for the distance travelled by a particle, which is given by u plus v times t over 2. So let's first of all work out the upper bound. The upper bound of s is going to require us to do the upper bound of the denominator. So we have the upper bound of u plus v t divided by the, 2 is just on its own, so we just leave that as 2. We can't change that. So we need the upper bound on the top of our fraction. So we need to do the upper bound of u and v, so that when we add them, we get the biggest possible value, and we then times by the upper bound of t. So the upper bound of u is going to be 15.5. The upper bound of v is 22.5. And the upper bound of t is going to be, well, it's 10.4 to the nearest tenth of a second. Well, the nearest tenth of a second is going to be, so if I have 10.4, the tenths column has the 0.4 here. 1/10 is 0.1, so half of a tenth is 0.05. So if I want the upper bound of t, I need to add on 0.05. So the upper bound of t is 10.45. We can substitute this expression to our calculator. 15.5 plus 22.5 times 10.45 over 2, and we get an answer of 198.55 meters, because it's a distance. So that's the upper bound for s. And to do the lower bound for s, well, the number that we're dividing out on the top of the fraction needs to be as small as possible. So we want the lower bound of u plus v times t, all over 2. So the lower bound of s is going to be the lower bound of u plus vt. So let's work out the lower bound of u and the lower bound of v. So the lower bound of u is 14.5 plus the lower bound of v, which is 21.5, and this needs to be multiplied by the lower bound of t, which this time is going to be 10.4 take away 0.05, which should be 10.35. So we put that in, 10.35, All of that goes over 2. And now let's calculate this. So we have 14.5 plus 21.5, all times by 10.35, all over 2, which gives us 186.3 meters. And that shouldn't be millimeter, that should be meters. 186.3 meters. Which again, it's not as crazy a difference as before, because this time we're measuring to a much higher degree of accuracy. We're doing the nearest meter per second and then the nearest tenth of a second, which is actually quite accurate. So the difference is not so much. In fact, to one significant figure, both would be 200 meters.